All right, I think we can start. Sorry for the delay, the group photo took a little bit longer. This session will be about Mago, format, lint and analyze your PHP code. My name is Klaus Purer, also known as Klaus in the Drupal community. I'm a principal engineer at Jobico, where I've been working for a long time. Basically, I'm at this company since I started with Drupal, since 2008. I maintain a couple of projects in the Drupal community, for example, Coda, which is the implementation of the coding standards, the GraphQL module, which is an API for decoupled Drupal sites, and I'm also the maintainer of the D7 security group, which helps to get out any D7 security fixes. Although I'm doing less of that because Tag 1, the commercial provider, is really doing a good job, so I'm happy about that. Yeah, Drupal 7 is great. My skills and interests are information security, performance, backend development, architecture, design at our company, working with the developers, telling them what they should do or what's the right thing to do things. The programming languages I like is PHP and Rust also has a certain part in this talk today. Let's jump right into it. Why do we even do coding standards? Maybe you have asked yourself this question. The most important thing for me is that it should be easier to read and review code for the reviewer of a pull request. So what we do in the Drupal community, we do peer review. In many companies, we do this as well. And if you have a common format, a common standard, then it's much easier to spot any logical errors. Okay, these examples are a little bit bad, but you know what I mean. So in the left side, this is valid PHP. It's really annoying that this is valid PHP because it's so obvious that it's wrong. The braces around the if statements are missing. So you're trying to do an access check and you grant access. But of course, the second line after the if statement is not in scope anymore. So anybody has access. And that's how you get really bad security vulnerabilities if you don't follow a certain set of coding standards. And of course, the good part is that you put the braces, always put the braces. This is, for example, a rule that is enforced by Coda. So whenever somebody writes an if statement, we put the braces there, and it's much better. Why do we automate coding standards? The problem that I have seen, I have been reviewing code for a very long time. I'm also a contributor to the project applications EGQ, where contributors ask for access to Drupal.org to publish releases as stable versions and get actual security support. And I pointed out coding standard errors to them, and the people were really annoyed. They took it very personally, right? I tell you, no, we used two-space indentation here, and they didn't like it. They were really angry. So from humans, they take it personally, but then I found out if we take an error, that's when I introduced PHP Code Sniffer to the Drupal community, or actually working together with other people doing that, then developers will happily fix any output they get from a tool because they just take it as the law of the land and they have to fix it to get any further. They have no hard feelings against the machine. Fine with me, let's do that. What we also can do with coding standards, we can fix them automatically. So actually when you write code, you can get into a mode where you don't care about the coding standard. You write it how you want, and just it's important that at the end you execute the PHP code sniffer to fix your stuff, or execute other tools like Mago to format it in the common format, and then everybody's happy. So that's why we automate stuff. I already mentioned PHP Code Sniffer. It's an open source tool that is developed by people outside of the Drupal community, so it's used widely in the PHP community. And then there's Coda, which is a set of rules that are used within PHP Code Sniffer to check your Drupal code. And that's all that it is. We take a lot of existing rules from PHP Code Sniffer and can reuse them. That's great, so we don't need to write all the rules ourselves. But we also implement some custom rules on our own, how we do stuff in the Drupal community. What you need to do when you start using Coda is set up a phpcs.xml.dist file. The dist extension here is that it's the one that you commit to Git. So you can also have a phpcs.xml file, but I would not recommend to commit that to Git because then people can make a copy locally and overwrite any stuff they want locally for whatever reason. They might want to disable something temporarily and they can easily do it without interfering with the Git diff. That's why you commit the dist file and not the XML file. It also can be integrated with your editor, so you can use it in PHPStorm or in Visual Studio Code. Then you immediately see what kind of parts of your PHP file should be formatted correctly and are not formatted yet. How you install it, you install Coda, and that will install PHP Code Sniffer automatically. And what it does, it puts then an executable file in your vendor directory, and that's how you can run it. Let's look a little bit on an example PHPCS XML dist file. So this is the one we example use in Jobico. You define a rule set, you define on which files, which is also folder names that it should run on. For example, for us it's a profile, it's our Jobico profile, and in the web modules we have some custom modules, but we exclude the contributed modules that are also there, so you can have this file exclude pattern. And we also check our behat tests. We have to define a long list of extensions that Drupal supports, file extensions. And then we have the most two important entries in this file, which is the Drupal standard and the Drupal practice standard. And within those standards, you can make certain exceptions for stuff that you don't want. For example, in Jobico, we use a different deprecated annotation format. So we don't use the one that is used in the official coding standards for Drupal core and contrib modules. We also wrote a custom standard for Jobico, so we also have some custom sniffs that checks our code, so you can also do that. It's very easy to extend PHP code sniffer. You can look that up in the documentation. And then you can have additional rules, for example, this Levomat coding standard, which is also a dependency on Coda. We want to sort our use statements alphabetically. This is a rule that was recently removed from the Drupal coding standards because there's some disagreement in the community how we should sort our use statements. I personally think they should be sorted alphabetically in a case-sensitive, not in a case-sensitive way. Yeah, this is what we've been using forever. So you can also tune these coding standards to your need. How does the output look like if you run it? I'm using a shorthand ddef PHPCS. I will show you the script later. It gives you a progress. It shows you some statistics, how many errors you have. It points you to the exact line. This little X you see in the square brackets there means that this coding standard violation is fixable automatically, which is great. Whenever you see that, it's very good because it can be fixed automatically. But of course, there are some sniffs that cannot be fixed automatically. For example, Coda does not rename interfaces automatically. In the Drupal community, we have the standard to suffix every interface with the name interface. So for example, entity interface. If you would just write entity for your interface, it would give you a sniff error, but you cannot fix it automatically. What is important with PHPCS is that you run it in parallel mode. So there's this parallel command line option, and then it's much, much faster. The problem is you cannot say run it parallel and automatically figure out how many CPUs I have. So that's why I use this workaround with the nproc command. Nproc just is a command that returns the number of your CPUs, which makes sense. If you have 8 CPUs, you can check 8 files at the same time. Checking more files doesn't really make sense because there's no CPU to do the work, so this is good. We also use a ddef shortcut command, as I already have shown you. Then you can run ddef PHPCS, which is just a very thin PHP script which does this parallel mode, which is important for us, and also takes any argument behind it, so you can run it just on one file instead of on everything. If you don't specify any file, then it would just check your PHPCS file, which folders it should check, and run on that. It's also very important to run PHPS in CI, then you can make sure that you don't have any coding standards regressions. This is automatically done on drupal.org GitLab. In the standard template, if you use that, it's executed, so that's very good. If you use ddef, you can just run this command, ddef PHPCS, as one of your commands in your continuous integration configuration, so it's very easy to integrate. There's some advanced stuff you can do with this reporting stuff. So many continuous integration runners support this JUnit XML standard, and PHPCS can also output into that format, and then the CIs can display it nicely. I don't personally use it, but you might want that. So PHPCS, we saw before, checks the coding standard, makes some output, but I think the even better tool is PHP Code Beautifier, which also ships with PHP Code Sniffer. So when you install Coda, you also have this tool already. Again, it's important to run it in parallel mode, then it's much faster. And what's really great is that it fixes all the stuff that is fixable automatically for you. Again, we do the same thing. We put a PHP CBF bash command into ddef, and then we can run it really quickly. It also automatically runs the parallel mode, and that's very good. How do we ignore some errors? So for example, we didn't fix the global class usage of Drupal in this one file we have in some GraphQL, whatever plugin we have here. And we can do this with an exclude pattern. So whenever you don't want to fix something or you can't fix something, go your config file, make those exclude. But what I like even more is doing it directly in code next to the code, because then you directly see in the file, this is ignored. So for example, a big problem we have in the Drupal community is that all class properties should be camel case, but for some entity properties or plugin properties, it needs to be snake case with the underscore. So PHP code sniffer would throw an error here that you should use camel case, but you can make an exception telling it, hey, ignore this specific rule, but anything else that would be wrong on this line, it would still report, but we just want to ignore this single rule. You can also just put PHPCS ignore without any sniff, then it will ignore everything on the next line, but that's not a good practice because then if something else is wrong on the line, it will not flag it. So what is my proposal, how you get started? Let's say you have some Drupal site and you want to start using this coding standards checking. You will get a lot of errors in the beginning. My approach, and this is, you don't have to follow this is just my recommendation, best practice. First, you run PHP CBF on everything so that you get the auto fixes out of the way. So this will be a huge diff, it will be a really big change, it will be very hard to review. It's not great for your Git history, but then you only have small formatting issues left, and then you can work with that to exclude or include more and more rules in your PHPS config file until you have fixed all of them. I can recommend using LLMs. LLMs are very problematic and their ethical use is very questionable and they have very questionable output. They are always a little bit wrong, but for simple cases like this, it can be good that you just give the PHPCS command to the LLM and tell it fix all the violations, and then most of the time it fixes it really good, so it can make you faster. Yeah, you should also enable it in continuous integration in CI so that you don't get any regressions. You fix the coding standards, then somebody writes some new code, and that should be checked immediately so that you don't get a mess again. And then you work your way up and enable the sniffs one by one and repeat basically the step 3 until you're happy with the configuration. I have never seen a Drupal project where there are no exceptions or no tuning in the PHPCS config, because every software team is a little bit different. They have some preferences. They also might want to import more strict rules from some other coding standards, so that's totally fine. You don't have to fully comply 100% to Drupal coding standards, because these tools are very strict, so they find very minor things. If you comply to a lot of them, it's already very good. We also use this approach in Drupal core, so Drupal core also does not comply to the Drupal coding standards. Ideally it would, but we are working on it since 10 years. We will get there eventually, and that's also the approach. We enable the sniffs line by line, then fix all the code and work from there. What you can also do, switching away from coding standards now, is linting. PHP has a built-in linter that you can run basically on compile time, or not on runtime, but basically before runtime, that checks your code for syntax errors. This is very primitive, so it does not give you a lot of benefit, but if you want to make sure that no invalid PHP code gets into your Git repository, I would recommend to set this up in continuous integration, and then at least you don't have invalid PHP when you deploy it to your production site. There's a warning, this will not find runtime errors. If you're calling a function that doesn't exist, this tool will not find it, because PHP does not run the autoloader or check which functions would be actually in scope. It's purely static. So we run a linting script like this. I will publish the slides later so you can copy this or modify it for your own needs. We do a similar thing as with PHP Code Sniffer, go through the folders that we have in Jobico and run the php-l on it, and if there's a problem, we exit with an error code, and that's good enough for us. Nowadays, usually this doesn't trigger at all, because the IDEs and the static other tools that we're using are really good at flagging errors. So I think PHP linting is totally optional. You don't have to do it in your continuous pipelines, but it can make sense. Now let's talk a little bit about static analysis in general. Beyond the syntax of PHP, we can also check the structure and the semantics of the code. Does it make sense how it works together? What is important, that you only call functions or methods that actually exist. So the assumptions about your types in code can be validated. And you can help these tools by putting function parameters everywhere, or by putting types everywhere, putting it in the function parameters, putting the the types on your properties on your class, putting it in return types. Also important, put it in type comments. So for example, if you have an array, PHP doesn't have generics or some collection concept, so it only knows about array, which is very generic. And then in your param annotation, you can put int with the square brackets, and this tells static analysis tools that only a list of integers should be passed in, not an array of anything. Yeah, there's other examples that you can help use the : class syntax. So in Drupal, we reference plugin classes often with strings, which is not good. And the string of a class, you can actually use the class name and : class. Then the static analysis tools can detect that and verify that the class is still in your code base, that this is actually in class in scope. I also think that static analysis is a good guardrail for LLM generated code. So as I said, the output of LLMs, unfortunately, always a little bit wrong. And this is a good guardrail for this code to make sure at least the types are correct, they are validating correctly. It doesn't hallucinate some class that doesn't even exist in your Drupal code base. Yeah. So here's an example, or a bad example, and we saw this a lot when PHP didn't have primitive type hints, when it didn't have, when people were not really using type hints, then a very old function in PHP would look like this. You have 3 parameters. Okay, the developer, at least they put the comments there so you can figure out what it actually is. But from the static validation point, it's very bad because you don't have a return type hint here, you don't have parameter type hints. There's another code smell in this example. Any guesses? What do you not like about this? The return is missing is correct, but there's another one. Exactly. So we have in the string, as I said before, we should use the class syntax. Very good. There's another one. Yes, very good. So this is actually a best practice in Drupal, and we do this all the time, but the wider PHP community disagrees a little bit. As you can see in the if statement, it gets the route variable from some getter. And this is a shorthand for assigning a variable in an if statement, which is valid PHP. Many people do it. We do it in Drupal very often. But in an if statement, actually only comparisons should be used. So this is a bit of a code smell. Currently, it's not a violation of the Drupal coding standards, but yeah. I would prefer that we only do comparisons in if statements and an assignment line before it. It costs you only writing one additional line, and the code is more clear.
Is there an existing rule that we could import if we want to prevent this?
Yes, so PHP Code Sniffer has a rule that could check this, so we could just use this. So how does it look good? We put all the types there. I also made a change to the param comments. If we go back for the first parameter, we just had array. Array is bad. So whenever you see array in a comment, it's not good. Think about what is actually in the array and put as a good type as you can think of there. In this case, for example, if you want to have it to be an array of integers, we put the int in braces there. We have the class syntax here. We have the return type. Looks much better. How do we do static analysis in Drupal? We use a tool called PHPStan. It's a command line tool. You install it with Composer. There's a very active maintainer, Andre. I really like him. He does a good job. I don't like the source code of PHPStan, so whenever I want to submit a bug fix or whatever, I just cannot find my way around because it's really complicated code, but it works really well. It provides rules to do static analysis. It's already used by Drupal core. I think we are currently at level 1. So the PHPStan configuration goes from level 0 to 9 for the amount of details it finds. You start with a very low level, fix the stuff, and then you move up levels, fix stuff, and so on. It's necessary to set up a PHPStan neon file. It's similar to the phpcs.xml file we saw before. And what I found, what we do at Jobico, we use level 6, which is kind of a good mix of, okay, we check really important stuff that should be checked. For example, that certain methods are really there that we are calling. But then if you go further up a level, it gets really, really picky, and you would need a lot of type annotations that I currently don't like. And the problem with Drupal code, of course, it's very dynamic. Entities are dynamic. You never know which fields exist on an entity because that is also dynamic. So we have a little bit of a difficulty there in Drupal with our dynamic types. You run it locally as a command line tool with the analyze subcommand, but you can also leave that out. I think it works even without it. And you install it with Composer, as I said. Some other plugins that I recommend for PHPStan. So we have here, the most important one is the second line from Matt Glaman, which is the PHPStan Drupal integration. So it gives you a lot of benefit for Drupal sites enhancing PHPStan. But we do also in Joby Code, we do mocking with prophecies, so that one is good to detect types there. We do extensions with PHPStan, so you need this extension installer. Some deprecations rule we also want on PHP unit integration. So that's the set we use, and that is helping us to make better detections of types in test code especially. How does the PHPStan Neon look like? There's a huge parameter list. We put it at level 6. Here's an option to report unmatched ignored errors. So you can also put in code these ignore statements. And if it ignores something, although there is no error, then it will report an error. So you always clean up your ignore statement, which I think is good. Again, we specify the paths we want to check. We specify excludes, we want to exclude. File extensions, it's very similar. We switch off the treat PHP doc types as certain because some documentation in Drupal core is outdated and doesn't have the correct type that is actually returned of a method. And then you get some false positives here and there. Hopefully we can switch this on soon, but for now I left it off. You can also ignore errors, which is important. So some stuff is best practice in Drupal, like our new static pattern or whatever. Yeah. So you can exclude stuff by the name of the rule, which is new. I think it's new in PHPStan too, so you should definitely do that. But the last 3 ones to ignore are just regular expressions that also still keeps working, so you can also use that. It's also important to specify which objects have universal properties, like custom fields, and if you define all those interfaces here, entity interface, field interface, type data interface, and so on, then you will get less complaints about property access that don't exist, because PHPStan knows, this is a class that can have any property because it has a dynamic isset and getter, then it knows that. There's also Drupal integration from the Drupal PHPStan integration from Matt Glaman. So you can specify the storage for each entity class, and that helps you with, I think with entity loading, then it automatically knows which types comes out of a storage controller loading command. So that's helpful. Define all the entities you use in your code base there, which is a little bit annoying to do in the beginning, but once you did it, it will help you. How does PHPStan output look? You run it like this. You don't need a parallel mode, so PHPStan does that smartly automatically. So it fans out to all your CPUs and tries to run as fast as possible, which is good. It's still very slow, and then gives you the errors. It also points out the name of the rule, so you can copy it from here to put it in an ignore file, or copy it to put it into an ignore statement in your code. And the ignore statements look like this, very similar to what PHPCS and what all these tools do. You give it a special name, PHPStan ignore, and then the name of the rule. And then it knows on the next line, ignore that we are missing a type for the count here. And this happens often in Drupal because we are extending classes, and sometimes PHPStan is not smart enough that this is a method override, and it tells you, hey, you should put a type here, and then you say, I cannot put a type here because the parent method also doesn't put a type here, and then you sometimes need those ignore statements. Maybe there's a better way to solve this. Let me know if you found it. Doc types annotations are very important for PHPStan. As I said, Drupal code is very dynamic. We have dynamic entities with dynamic fields, so PHPStan cannot know what is coming out of this get items. It's a field of orders, order references. So that is an order item in there, okay. But we know in this case it can only be product variations because we never put anything else in this field. So we make the assumption, we tell PHPStan, no, we know this is a product variation interface here, nothing else. And we do the same here for this entity reference call. This is also a common pattern. You access a field, which is the product ID, and then the entity of it, because this product ID is an entity reference field. But then, of course, PHPStan is completely lost. It doesn't know what type comes out, and that's when you then can put these annotations there and tell it, okay, this is actually a product, and then you can call normal entity functions or whatever on it. Yeah, so the comments are very important. You override what PHPStan reasons of your code, so be careful with that. How do you get started with PHPStan checking? Very similar story that we have with PHP Code Sniffer. You start with level 0, which basically checks that all classes that you use actually exist in your vendor folder in Drupal core, which is very good. Again, LLMs are quite good at doing that. So with all, of course, you need to review what it fixed and how it fixed it, but I think it can make you a little bit faster. What is also very helpful with PHPStan, it can give you a baseline file. What is a baseline file? Let's say you start with a code base that has many violations, and what you make sure, okay, at least for all the new code that we write, it should be good and it shouldn't have any issues. So you can export the current list of errors into a baseline file and then run PHPStan with that, and then it will ignore all of those. And once you clean it up, you can modify the baseline later. And the good thing is, for all new code that you write, all the sniffs that you want will be enforced and you don't have any regressions there. So then you move your way up to level 1, make the fixes, commit it, push it, go for level 2, and so on. Fix or modify the baseline as you see fit. And then you repeat basically the steps. And then you end up at level 6, which is my preferred goal, but the higher the better, I would say. It just means you need to put more type annotations in your code and need to maybe have more if statements, more is-set checks and such code, even when you know this value cannot be anything else at this point in code. PHPStan will force you to still write some comparisons, which I find a little bit inconvenient. Now let's look a little bit at Mago. Mago is a newer project for checking PHP code. It's written in Rust. So Rust is a high-performance systems programming language. Compared to PHP, it compiles before it runs, so it can really output optimized machine code, which is similar on the performance of C and C++, so it runs really fast. Mago is quite a beast. It has many tools included at once. So it kind of tries to cover PHP code sniffer, PHPStan, even PHP mess detectors in one CLE tool, but it's split in subcommands. So you have a format check, you have a lint check, and you have a static analyze check. The big advantage is, of course, performance. It's really, really fast. Like PHPStan runs in minutes, and Mago runs in seconds. For formatting code, it formats all of Drupal core in 1 second, which is really great. Although the Drupal support is very basic, so I just started looking into it a couple of months ago, and I submitted a preset for Drupal so that there is some configuration in Mago to enforce Drupal coding standards already. But I think it's not mature at all yet, and I think it's not ready for prime time yet. But if you want to play around with it, use the Drupal preset. The interesting thing is you can install it with Composer. I was also surprised for that, like how does it get the binary? And what it does, it puts into this Mago executable in your vendor directory, it puts a thin PHP script that checks, do we have the binary already? If not, download it from the internet, which is, from a security standpoint, not great, but at least you can get working with it very quickly because it figures automatically the CPU architecture, what you need for the compiled binary. The documentation I find is also quite good on this page, so check it out. Let's check the performance a little bit. So if I run PHP CS in parallel mode on Drupal core, it runs in 27 seconds, which is, yeah, it's okay. You wouldn't run it all the time. But with Mago format, the initial run is 1.3 seconds, and the rerun, where it doesn't have to fix anything, is just 1.1 seconds. So it's 20 times faster. If you compare PHPStan, runs roughly in 2 minutes, but Mago lint, where we just do the lint check-in, it's on a similar speed than the format. It runs in 1.3 seconds, and the analyze is a little bit slower because it needs to build all the abstract syntax tree of all the included code you have. It runs in 5 seconds, which is still a lot faster. And if we have this 1 second formatting time, means we can use it in a lot of more places. You can use it on every save in your editor, in every commit hook. You can put it in continuous integration that it even formats the code automatically and pushes that again. You can start thinking about that because you don't have these long wait times until everything is checked. How does the configuration look like? These tools are all very similar, so we have seen this pattern before. You define where the workspace is, what kind of paths you want to check. This is an example for Drupal core. You say, includes is important to say we need to check the vendor directory to build the abstract syntax tree. So it uses the file, the code from the vendor directory for checking your code, but it does not check the code in the vendor directory. You can define some excludes, like node modules or whatever you have that you don't want to check. So probably for Drupal core, there should be many more excludes. Just for brevity, I have those. File extensions is very familiar, what we have in Drupal core, PHP files, include files, module files, and so on. Then important is the formatter section with the preset Drupal. So if you get started, use that. And if you then you need to make some exceptions, put the rules under it. In this formatter section, you can basically turn off and on certain formatting rules that you want or don't want. There's also integration helpers for Symfony and PHP unit, which also apply to Drupal, so I included those. Although I have to say I didn't test the linter much. I'm mostly focusing on the formatter right now. What's the Mago format philosophy? And that's a little bit different. Like we think about Drupal coding standards in the Drupal community is we don't output what the errors are. Mago doesn't do that. Mago just formats. So the assumption is we do whatever Mago tells us to do. We don't discuss the coding standards. We don't argue what should be done where. We just take whatever Mago writes, we accept that. It's fast, just run it all the time and be happy. In this way, it's like PHP code sniffer, like it also does the same thing, fixing stuff automatically. Yeah, and also this is also a design goal of Mago that it says we don't want to debate code style. We don't even want to debate the error codes, just format it and stop worrying about it. So this would also be a shift in the Drupal community, right? Because Mago also puts, if a line is too long, then it makes the line short and puts, for example, chained method invocation on the next line. In Drupal coding standard, we have a soft span of code of, I think, 80 characters right now. And Mago just formats it and break the line, which is technically not a coding standard violation, but Mago still does it. And this could lead to conflict with PHP code sniffer. But I will talk about that later. Currently, Mago format is incomplete. If you look at this code example, Mago doesn't do anything about it. So in the Drupal community, compared to other PHP communities, we want to document our code. I know there are many PHP projects out there that just write PHP code in one file and there's not a single command. You have no idea what it does, no explanation. In Drupal, we love to write comments, and I think that's good. That will also help us with LLM integrations. But if the comments are not formatted correctly, Mago will just leave this in place, which is not great. There's an open issue that it will also pass doc comments, for example. And I'm sure we will find other formatting stuff that it currently does not do. But I think you can slowly work on it and make the support in Mago. I have to say the maintainer is very responsive. I like him a lot. He's doing a really good job making regular releases of Mago, although it's a very young project, making good progress. Mago lint and analyze is, we have a lot of autofix implementations, so that's great. So as on format, Mago focuses on formatting code for you, even with the linter. I ran Mago lint on Drupal core and autofix everything, and it failed with the memory leak. So I reported the memory leak to the Mago maintainers. So it was eating up all the RAM on my computer and crashing because it found 180,000 issues to fix in Drupal core. Of course, that happens because we have dynamic fields and so on, you know the story. We also don't have configuration best practices for the linter and analyzer yet, so that's still yet to come. I think we just got started with this. But if you want to try this, and there are certainly some lint rules that you want to use, I recommend to put in this lint section to exclude all the lints that you see not applying to Drupal and just run it with the rest. And I think you will still get some good recommendations. How does Mago output look like? So you run the Mago lint, and what's even better than on PHP code sniffer, unfortunately I don't have color support here, but it even gives you a colored output. Didn't copy over when I copied from the terminal. And it even points out on which line and which column the problem is. So it gives you an even more detailed pointer what you should fix and what the problem is. So for example, in this example, we forgot to put the declare strict types, which is a modern PHP standard. And it gives you a hint about that if a function callable does not use the this object, you should use the static keyword with it. Okay, why not? And for analyze, it looks very, very similar. I also ran it on Drupal core. I found some interesting things. So for example, some invalid tag we have in some code that we didn't detect with our tools, which is interesting. So Mega Analyze finds stuff in Drupal core that we are currently not detecting with our tools, which I think is good. All right. Ignoring, I will skip over this a little bit because it's very similar to the other tools. Either put it in a config or put it in the source code. Very similar, as you already know. You also can generate the baseline. I already mentioned this with PHPStan. Completely same approach with Mago. You say, okay, my current code base is bad, but for all the new code I write, at least I want to check the issues from the beginning. Generate the baseline, it exports to this TOML file, and then when you run it again, you give it this TOML file, and it will check it with the lint or even with the analyze command. What's the plan to integrate Mago into Drupal? The plan is that we integrate PHP Code Sniffer and Mago at the same time. So in the beginning, I thought, okay, all that Mago format does and what PHP Code Sniffer does, it needs to be the same so that we don't have any conflict. But I think as Mago is very opinionated, I will give up this approach. And what we will do is define a new PHP coding standard where we just define the rest. So whatever is not implemented in Mago, we will have in this new Drupal Mago standard. And what Mago already covers, we can just let Mago run. This will be totally opt-in, right? So we will not break anything for your current pipelines. But in the future, you can use this new Drupal Mago standard with PHP Code Sniffer, then it will only check the Drupal-specific things and give the formatting completely to Mago. I'm also planning to look into the CLE commands because maybe it's good to have a helper method which generates the Mago config file for you. So if you set up your project with PHP Code Sniffer already, I think it would be very quick to make a Mago config out of that, and then you can run it immediately. Also, the list of tools that you need to run is very long. You need to run the Mago format, you need to run the Mago lint, analyze, PHPStan, PHPCS. So maybe it's a good idea to bundle that into a wrapper command line tool, but I'm not sure yet. Depends how complicated it is to run this tool and how it looks in continuous integration. And I think we need to start writing also documentation, what other people are doing with Mago, so that we kind of get the best practices and get them documented. What's the current state of Mago? Just to repeat, does Mago replace PHPCS or PHPStan? No, not yet. It probably will take years until we get anything close to there, but I want to explore it more just because it runs so fast. Many checks, as I said, are not available in Mago. Many checks cannot be applied one-on-one to Drupal, so we need to make exceptions for that, which apply to all Drupal sites. And then the question really becomes, what's the point? As I said, I would like to explore it and eventually replace it, but it will take a long time. How do you get involved? You can test Mago yourself, and if you report any issues, open the issues there, and the maintainer is very responsive, so I like that. We have a Coda issue where we have the plan to create this new Drupal Mago standard, which is very good. You can also join the coding standards channel on Drupal Slack, and you can discuss coding standards changes with the coding standards committee at the coding standards project. So if you think the Drupal coding standards should be changed for anything we are currently doing, go there and check out the issues. Before we close, I think we might have not really time, but just to to show you how it looks like. So currently I have a clean Drupal core checkout, and I installed Mago in the vendor directory. And if I run the Mago format command, so currently nothing is formatted. As you can see, it runs in 1.2 seconds, which is really fast for 7,000 files. I think that's really great. And if you look at the diff to check what kind of stuff is it fixing, of course the git diff takes a long time. Then you see examples with this too long line rule, for example. So this line before went over 80 characters, and Mago tries it split up in a smart way over multiple lines. Same here for chained method invocations. So the biggest diff thing that you will see is changing double quotes with single quotes, because if you don't use any variables in the strings, you should use the single quotes. It's also a Drupal standard. What else? Yes, again, the single quotes, nobody cares. We've seen this before. Use statements, so Mago is the opinion we should order the use statements alphabetically. It wants to align chained method calls nicely. That's why it puts this name call on the second line, which is, it's technically not the Drupal coding standard violation, right? But yeah, I think it's better. It's more consistent. And I think that's about it. Yeah, especially when you have deeply nested code, then you get the diff like this. All right. Thank you. Any questions?
Is it on? Okay. I missed one tool, so you didn't mention Rector at all. Was it by accident, or because I feel there are a lot of overlaps between all those tools, because Rector can also has a preset for coding styles, coding standards.
Yes.
So I feel, for me at least, most of the time it's easier to write a Rector rule than a sniff for PHPCS. So do you have any plans to make a broader use of Rector for the coding standards? Because it's
currently not. If I would go the Mago direction. I want to fix coding standards fast. That's why I wouldn't use Rector. Rector again is PHP, so it's slow, right? So if I take the time to write new rules, I want to do it where it really has an effect and where it makes a good impact. So I would go the Mago route. The problem with Mago right now, it doesn't have a plugin system. So currently all the rules that exist must be in Mago core, which is a problem. But there's an open issue that in the future there will be plugins. I think the approach will be to compile the plugins to WebAssembly, and then the binary can load it dynamically, which will still be lots faster than Rector, for example. I think Rector is a great tool, especially if you just have one deprecation thing you need to fix, you can just run it. I didn't put Rector in this talk because I'm not that familiar with it, so I'm not an expert on it, how you most effectively use it, and I had a lot of content, so I didn't mention it. But it's a very good point. And Rector is a great tool, yeah.
Maybe a little cheeky to phrase this as a question, but did you know that the PHPStan maintainer recommends using assertions over @var annotations? Because if they ever become untrue, then your tests at least start failing. And for the interpretation of PHPStan, it's the exact same.
That's a good point, yes. I didn't know that the PHPStan maintainer says that, but yes. It's just such a wide practice that we put it in the commands, but maybe we need to make a harder push to make asserts. I think your point is very good, that because then you enforce it also on PHP runtime, then it's automatically enforced in tests, so the test will fail if the type is not what you expect. I think that's a very good point. Yes.
Yeah, the only place where it fails is in generics or collections, because you cannot directly assert that, but those are rare.
You get a small performance penalty, but I think you can disable the assertions on production. Yeah.
Thanks. A little bit like with a question with Rector about PHP CS fixer. Then I guess in this case, if you, like mentioned, if Mago got a plugin mechanism, then I guess we can also bypass the possibility to also have Drupal rules for PHP CS fixer and go directly to Mago.
Yes, so PHP CS fixer is kind of a competition to PHP code sniffer. It's also a PHP coding standards fixer, I think, written by the Symfony people mostly.
Yeah.
But yeah, I have the same issue with that as with PHP code sniffer. If I put my work into something, I want it to run really fast, and currently Mago seems like the better option for that. Yeah.
Thanks.
Okay. Thank you.